I'd like to turn to our last presenter, Mr. Jeong tack of the Korea Institute of Robotics and Technology, Covergence. His presentation is titled "The Development of Standard Manufacturing Technology for Marine Leisure Vessels and Safety Support Robots for Underwater Leisure Activities." And Mr. Dr. Min has been serving as an expert member of the ICT Covergence and large research facilities at the National Science and Technology Advisory Council since 2023. Please welcome him with a big hand. Thank you very much. I'm Jeong tack, as introduced. This is the last session of the day, and I'm the last speaker. Well, thank you very much. I feel very much honored to be the last one in today's program. Today, I'd like to talk about the development of standard manufacturing technology for marine leisure vessels and safety support robots for underwater leisure activities. You can see right next to the marine city, many people enjoy yacht riding. And in every beach in Korea, you can see surfing boat. In Jeju and in other islands, but there are many divers in the MZ generation. And then we have to consider whether we are creating a healthy and safe maritime leisure environment. And we have to also consider whether SMEs are strong enough in this industry. And I think these are very important factors when it comes to the safety as well as the economic feasibility. And the Ministry of Oceans and Fisheries understands the importance of these two issues. And I'd like to talk about the ministry's project in order to deal with these two aspects, which I am part of. Within the scope of my project, there are three different parts. First, the vessel for divers, and on the right side, and sailing yachts. SMEs can take part in terms of design, but they do not have technological capability. That is why we provide a relevant technology, but that does not ensure their global competitiveness. That is why in this case, we would incorporate ICT. As for diver vessels, it cannot be purely electric propulsion. That is why it is hybrid, and as for sailing yachts, and it is hybrid system as well. So above the surface of the water, these are the two main parts, and below the surface of the water, there are so many diver-related safety accidents, so we have to ensure the safety monitoring. So underwater assistance and biometric information generation of divers, the wearable device is the concept we use here in developing diver suit. So these are the three major items within the project. And this project is a 6-year project with a budget of 44 billion Korean won. So you can see that there are three major projects, and number 4 is if the business goes well. Number 4 is to create some infrastructure for experiments as well as the laboratory projects. And I would not focus on number 4. I will focus only on 1 through 3. As for the key performance index, we have to produce some output. That means quality products, well-performing products, and well-functioning products, as well as the papers and business setup as a result of this project. And we should be able to catch up with European countries in terms of the leisure vessels. And as for the diver suit and a leisure yacht or other equipment, that's first in the world. And as for economic feasibility, our goal is to strengthen competitiveness in the upstream industry, and so that we can expand the market share domestically and in the global market as well. We hope that we can revitalize the marine leisure industry in the local city. Now I'd like to turn to standards manufacturing technology of marine recreational craft. There are two main pillars. There are one hidden actually on the left side. You can see the sailing vessels. We do all the design and even fabrication will be done by us. And this is electric propulsion system. And on the right side is diver vessel, and this will be 30 feet hybrid engine using electric propulsion as well. Then Abacus is part of this project and this part for autonomous sailing. And the third pillar is about safety. Many people use fishing boats for diving experience, but the fishing boats do not seem to be safe enough to prevent any accidents, especially in and around the area of propeller. And we are doing this project in order to introduce various devices in order to ensure the safety of the divers. Now we are ready to go for detailed design. And as for the vessels for divers, we are doing concept design. And we are working on the concept design. And this is something we are doing with the global market in mind. And so on the right side, we have almost completed the concept design. And what's the key here is that, as you know, the autonomous sailing is very popular these days. So regardless of the size, since because it has such an advanced technology, we can easily adapt and then implement this autonomous sailing technology. This is not part of this project, and autonomous driving and autonomous sailing is for birding part for sailing, yacht sailing. And another part is to recognition of the divers' movement in order to follow the movement of the divers. So when divers come back to the surface of the water, then they can easily locate their vessel. And the third part, this is about safety. The propeller in the fishing vessel is the area where we have the most number of accidents. When divers coming back to the surface, then sometimes they turn the vessel operator would turn on the propeller, and when the propeller starts to run, then that might cause such a dangerous situation for divers. And there is a legal guideline, a legal requirement to place a guard around the propeller, and how to place it and how far they should go when it comes to this guard, propeller guard. And that is why we worked on this project. And as you can see, most of the companies working on the installation of the guard without calculation of the resistance, well, they just place the guard. That's it. This is not effective. And on the right side, you can see it looks very heavy, and it looks too large. And my organization is working on this. And for all the vessels, we conducted an analysis. As the project manager of this item, I was truly surprised. Most of the fishing boats is 4.99 tons, but when it comes to the propeller, they are all different, and all the designs are all different for all those vessels, even for the same tonnage vessel. That is why we need to go for the optimal design of the propeller, and that should be propeller as well as the guard, and they should be affordable. So we conducted a survey of this, as you can see on the right-hand side. We went for the least resistance. Early October, Quito conducted a pilot test and a field test in Jeju Island with a guard, without guard, and on the right side, that's our guard when we conducted the testing. In terms of the rotation, we attached a sensor to do the demonstration, and the demonstration produced the outcome that in the past, the existing vessel would have about 15 knots. Any regular guard would reduce the speed to 10 knots, but our guard would enhance that to 12 knots. And energy consumption-wise, this is very important. And we are to promote this further, and we are also considering monetizing this item and idea. And the next one is underwater robot. As I mentioned previously, there are so many diver safety accidents. When there is an accident, most of them lose their lives. And we conducted a survey from 2000 to 2013. When there is any diver accident, there is only one rescue out of 310 accidents. And then what kind of approach we should take? So underwater robots target is like this. There are two different types of diver: professional diver, and they have a clear goal they want to achieve, and for welding, for example, and for recreational divers who enjoy diving in Jeju Island in various parts of the country with the professional trainer. And if you have this robot, that you can ensure the safety monitoring even without anybody or assistant. And even professional divers, they're supposed to work in pair, but because of cost issues or because of other matters, they usually would go down all by themselves. The design would be updated, but this is just the implementation of the concept design, and it should be as light as 60 kilograms because two persons should be able to lift it. And what's really important is to recognize diver underwater if there is any customized manipulation to be conducted, or if there is anyone to be rescued, and that should be able to be done with this underwater robot. And an integrated control and support system should be realized and implemented for this one as well, as we can see inland. I cover all different areas here since we cover design and safety. Two big categories here. And my underwater robot is considered highly only when it fulfills its functional purposes. And the next one is about diver suit. And a diver suit is a whole new concept. And it is composed of a diver mask and head-up display for presenting information. And the suit would receive senses and signals from the body and transmit the information and the data signal to the system. And if there is any issue, then the diver should be able to be rescued, and there should be a diagnosis at hospital later. But even underwater, such a diagnosis should be made in order to see whether the diver is conscious or not. Currently, there is no data collected while the diver is underwater. This kind of data will be quite important and useful for the diagnosis at the hospital. So we are working on the clinical test of this item, we'd like to know whether this is feasible or not. So in this case, we should incorporate the medical perspective as well. The top left, that's the evaluation of the effect on the human body from the IRB perspective. If the gaze is not clear, then that will be captured and then that will be detected in the system. And for vital signs, we are also developing various wearable devices. And I believe here we need to take a design-conscious approach. Technology is there, but if we really want to commercialize this idea and this item, I think we need to consider the aesthetic aspect of these items. Although my time is up, I would like to share with you the project we are preparing for. The first one is that, as you know, in the birding and unbirding, well, there is high risk of accident. So, as you know, we have this parking robot system. Once that's fully automated, we wouldn't need such an assistance system, but it will take some time for roads to fully adopt this automation system. So, I think, well, birding and unbirding assistance system is something we can consider for development. And lifting the vessel and the sleeve, I think, well, that's where we can combine the robotic technology as well. To help the unloading and loading to make marina smarter. So these are the areas we are considering for the next project. Thank you. This is the end of my presentation. Please give him another round of big hand. Thank you for sharing with us various cases. We'd like to move on to the panel discussion. Before that, we'd like to take a group photo. I'd like to ask the chair and the presenters as well as the panelists to come forward so that we can take a commemorative photo. Thank you.